If you are over 60 years old and night driving has started to feel genuinely scary, if oncoming headlights blind you, if dark hallways take far too long to come into focus, if you have begun avoiding highways after sunset, I want you to know something important before we go any further. What you are experiencing is not just getting older. It has a name. It has a biological cause. And modern science has been actively studying a very specific solution for decades. Today we are going to walk through all of it: the cause, the science, a remarkable wild European berry, and what the research actually tells us. Stay with me until the end, because I am also going to tell you exactly what the research does not yet prove, because your trust means everything on this channel, and we never oversell anything here. Let us start with the science, because understanding why this happens is the key to understanding what might help. Inside your eye, sitting at the back of your retina, are millions of specialized cells called rod photoreceptors. Rods are your night vision cells. They are extraordinarily sensitive, so sensitive that under ideal conditions, a perfectly dark adapted young eye can detect a single photon of light. But here is the critical point. For rod cells to function in low light, they depend on a light-sensitive pigment called rhodopsin, sometimes called visual purple. Rhodopsin is the molecule that actually catches incoming light and converts it into an electrical signal that your brain interprets as vision. Without sufficient rhodopsin, your rod cells are essentially blind. Here is how the process works. When you walk from a bright room into darkness, your rhodopsin has been partially bleached or used up by the bright light. Your eyes now need time to regenerate that rhodopsin so your rods can become sensitive again. That process, the rebuilding of rhodopsin in darkness, is called dark adaptation. In a healthy 20-year-old, dark adaptation takes roughly 20 to 30 minutes to complete. But a landmark study published in the journal Vision Research, which measured dark adaptation in 94 adults spanning their 20s to their 80s, showed that the rate of rod-mediated dark adaptation slows measurably with every decade of age, and by the time someone reaches their 70s, the time needed to reach full dark sensitivity can be more than 10 minutes longer than it was for the same person at age 20. What causes this slowdown? It is not simply about your pupil getting smaller with age, although that does play a minor role. Researchers have identified that the primary culprit is a slowdown in the visual cycle itself, the biochemical chain of events responsible for regenerating rhodopsin. With age, the retinal pigment epithelium, a thin supportive layer beneath your photoreceptors, becomes less efficient at processing the nutrients and retinoids needed to rebuild rhodopsin quickly. Additionally, Bruch's membrane, which separates the retinal pigment epithelium from the blood supply behind it, thickens and accumulates lipid deposits over time. This acts like a slow-growing filter, restricting the flow of nutrients including vitamin A, the essential building block of rhodopsin, to your photoreceptor cells. The result is exactly what millions of adults over 60 are experiencing every single day: slower adjustment to darkness, reduced sensitivity in dim environments, more difficulty with glare from oncoming headlights, and a genuine loss of confidence. Blueberry you buy at your local supermarket, the cultivated American highbush blueberry, scientific name Vaccinium corymbosum, is actually a different species from the wild European bilberry, known scientifically as Vaccinium myrtillus, and the difference between them, when it comes to anthocyanin content, is substantial. Research comparing the two species, including a widely cited study using liquid chromatography mass spectrometry analysis, found that wild bilberries contained roughly 210 milligrams of total anthocyanins per 100 grams of fresh fruit, while commercial highbush blueberries contained approximately 212 milligrams per 100 grams. That means bilberries contain nearly 6 times more anthocyanins by weight. Wild bilberries contain approximately 6 times more total anthocyanins than commercially grown blueberries, and the types of anthocyanins differ significantly between the two species. But it is not just the quantity, it is also the type. Common blueberries are dominated by malvidin glycosides. Blueberries, however, are rich in cyanidin and delphinidin glycosides, including a specific compound called cyanidin-3-glucoside, abbreviated as C3G, and it is this distinction that makes bilberry the subject of serious ophthalmological research. There is also one other remarkable feature of bilberries that separates them from their cultivated cousins. Because bilberries grow wild, they have never been successfully domesticated or cultivated commercially. Their anthocyanins are distributed throughout the entire flesh of the fruit, not just concentrated in the skin. You can see this immediately if you ever eat a wild bilberry. It stains your fingers and your tongue deep purple-blue all the way through. A regular blueberry, by contrast, has pale green or yellowish flesh inside its blue skin. This distinction matters for bioavailability, for how much of those active compounds your body actually absorbs and uses. Let us now walk through what the published science actually says about bilberry and your vision, because this is where things get genuinely fascinating, and also where intellectual honesty becomes critically important. The most studied proposed mechanism linking bilberry anthocyanins to night vision is their potential role in rhodopsin regeneration. Laboratory research published in peer-reviewed journals, including work in the Journal of Agricultural and Food Chemistry, has demonstrated that cyanidine glycosides, including the C3G found abundantly in bilberry, can stimulate the regeneration of rhodopsin in rod outer segment membranes under controlled in vitro conditions. That means in isolated cell studies, these compounds appear to interact directly with the rhodopsin cycle. The proposed mechanism involves C3G's ability to bind to the opsin protein, the protein backbone of rhodopsin, and facilitate the recombination of opsin with 11-cis retinal, the light-sensitive molecule that completes the rhodopsin complex. By potentially accelerating this step, bilberry anthocyanins may help your rod cells recover their sensitivity more quickly after light exposure. One of the remarkable properties of bilberry anthocyanins, confirmed in research studies, is that they are capable of crossing both the blood aqueous humor barrier and the blood retinal barrier, the protective biological barriers that separate the retina from the general bloodstream. This is significant because many compounds that are beneficial in theory never actually reach the tissue they are meant to help. The fact that bilberry anthocyanins can cross these barriers in intact form means they arrive at the retina, where they can potentially exert their effects directly on photoreceptor cells and surrounding retinal pigment epithelium. The retina is one of the highest oxygen demand tissues in the entire human body. This makes it exceptionally vulnerable to oxidative stress, damage caused by the accumulation of unstable molecules called reactive oxygen species. With age, the retina's natural antioxidant defenses weaken, leaving photoreceptor cells increasingly exposed. Research published in the journal Investigative Ophthalmology and Visual Science found that bilberry anthocyanins modulate the expression of heme oxygenase 1, a powerful antioxidant enzyme in retinal pigment epithelial cells. Additional studies demonstrated that bilberry anthocyanin-rich extract reduced intracellular reactive oxygen species and suppressed inflammatory pathways, included NF-kappa B and interleukin-6 markers of retinal inflammation in animal models of retinal inflammation. A 2012 study published in Laboratory Investigation, which used a mouse model of endotoxin-induced uveitis, a form of retinal inflammation, found that pre-treatment with anthocyanin-rich bilberry extract preserved photoreceptor cell function, maintained rhodopsin protein levels, and suppressed the shortening of rod outer segments that would otherwise reduce visual sensitivity. In an animal model of retinal inflammation, anthocyanin-rich bilberry extract preserved rhodopsin levels, maintained photoreceptor structure, and suppressed inflammatory cytokines, suggesting a direct protective effect on the visual cells responsible for night vision. Your retina requires constant, precise blood flow to function. Tiny capillaries, some of the smallest blood vessels in the body, supply oxygen and nutrients to your photoreceptors every second of every day. When these microvessels are compromised, visual function deteriorates. Research has consistently shown that bilberry anthocyanins strengthen the walls of capillaries by inhibiting enzymes that break down collagen and elastin, which are the structural proteins that give blood vessel walls their integrity. Additionally, a clinical registry study published in the European Review for Medical and Pharmacological Sciences, involving 140 patients with different types of retinopathy, found improvements in ocular blood flow measurements in groups receiving standardized bilberry extract. Improved microcirculation means better nutrient delivery to your photoreceptors, including better delivery of vitamin A, which is the essential raw material for rhodopsin production. Now, and this is where Senior Health Insights is different from a lot of health content you will find online, I am going to tell you exactly what the clinical evidence does and does not show, because you deserve the full picture. The mechanistic research is compelling. The laboratory studies are real, published, and peer-reviewed. The ability of bilberry anthocyanins to reach the retina, interact with rhodopsin, reduce oxidative stress, and support retinal circulation, these are scientifically documented findings. However, the picture becomes more nuanced when we look at randomized controlled clinical trials in healthy humans. A systematic review published in the journal Survey of Ophthalmology, which examined placebo-controlled clinical trials on bilberry anthocyanins and night vision, concluded that the evidence was not sufficient to confirm significant improvements in night vision in healthy adults with normal eyes. Several individual trials showed promising trends, but the results were not consistently replicated across all studies. What does this mean in plain language? It means that for older adults who already have well-functioning night vision, bilberry supplements may not produce dramatic measurable improvements in a clinical setting. The honest scientific picture, laboratory and mechanistic research strongly supports bilberries' potential benefits for retinal health. However, large-scale clinical trials in healthy adults have shown mixed results, and researchers note a significant gap in rigorous trials specifically targeting older adults with declining night vision. However, and this is a critically important nuance, that same systematic review and subsequent researchers have explicitly noted a serious gap. There is a meaningful lack of rigorous clinical trials specifically in older adults who already have impaired dark adaptation or declining night vision due to age-related changes. This is a fundamentally different population from healthy young adults with normal vision. The same review authors specifically wrote that plausible mechanisms exist by which bilberry could modify vision and retinal health, including accelerated rhodopsin resynthesis, antioxidant activity, modulation of retinal enzyme activity, stabilization of collagen, anti-inflammatory action, and improved microcirculation. Research using combined anthocyanin formulations, including a randomized double-blind placebo-controlled trial published in the Journal of Nutritional Science and Vitaminology, which examined 44 subjects over 6 weeks using a supplement containing bilberry-derived anthocyanins alongside astaxanthin and lutein, did find improvements in visual acuity and accommodative function in participants with eye fatigue. The researchers attributed these effects in part to anthocyanin-stimulated rhodopsin regeneration and reduced retinal oxidative stress. The bottom line, stated with scientific honesty, is this: bilberry's retinal mechanisms are real and well documented. The clinical evidence in aging populations with compromised night vision remains an active and promising area of research, not a closed case. I want to take a moment to tell you where the modern scientific interest in bilberry and night vision actually began, because the story is genuinely fascinating. If you are interested in exploring bilberry as part of a comprehensive approach to supporting your eye health, here is what the current evidence suggests, alongside important practical considerations. Fresh and frozen bilberries. Wild bilberries, known in the Nordic countries as blåbär, and in many parts of Europe by various regional names, are available fresh in season during summer and autumn, and are widely available frozen year-round from Scandinavian and Eastern European specialty food suppliers. Frozen bilberries retain the vast majority of their anthocyanin content, making them an excellent practical option. A serving of approximately 100 grams of frozen wild bilberries provides meaningful amounts of the anthocyanins associated with retinal research. They have a more intense, slightly tart flavor compared to regular blueberries, and work beautifully in smoothies, yogurt, oatmeal, or simply thawed and eaten as a snack. Standardized bilberry extract supplements for those who cannot access wild bilberries regularly. Standardized bilberry extract supplements, typically standardized to 25% or 36% anthocyanin content, are widely available. The most common dosage ranges studied in research settings have been between 160 mg and 480 mg of standardized extract daily. Quality matters significantly here. Look for products standardized to a specific anthocyanin percentage, from reputable manufacturers who provide third-party testing. Research has noted that some bilberry supplements on the market are adulterated or contain far less active anthocyanin than labeled, so source matters. Important note: always consult your physician or eye care specialist before beginning any new supplement, particularly if you take blood thinners, diabetes medications, or blood pressure medications, as bilberry anthocyanins may have mild effects on blood glucose and blood coagulation that are clinically relevant in these contexts. Supporting nutrients for retinal health. Bilberry does not work in isolation. For comprehensive support of aging eyes and night vision, consider a dietary approach rich in vitamin A, found in liver, dairy, eggs, and as beta-carotene in orange and yellow vegetables. Lutein and zeaxanthin, found abundantly in kale, spinach, and egg yolks, are scientifically supported for macular health. Omega-3 fatty acids from oily fish like salmon and sardines support retinal membrane integrity. And zinc, found in meat, shellfish, and legumes, is essential for vitamin A metabolism in the eye. Your overall dietary pattern matters enormously. A Mediterranean-style diet, which is naturally rich in colorful fruits, vegetables, olive oil, fish, and nuts, has consistent research support for preserving visual function as we age. Beyond nutrition, what else supports night vision? While bilberry and nutrition are central to today's conversation, I would be doing you a disservice if I did not mention several other evidence-based steps you can take immediately to support your night vision. Regular eye examinations are absolutely essential. Many causes of declining night vision in older adults, cataracts, early glaucoma, early age-related macular degeneration, are detectable and treatable. Delayed rod-mediated dark adaptation has actually been identified as one of the earliest functional biomarkers for age-related macular degeneration, sometimes appearing before any structural changes are visible on imaging. Your eye doctor can measure dark adaptation clinically and identify whether there is an underlying condition that needs treatment beyond nutritional support. Anti-reflective, glare-reducing lenses for night driving can make a significant practical difference. Modern anti-reflective coatings dramatically reduce the scattering of light from oncoming headlights, which is a major contributor to night driving difficulty in older eyes, separate from the rhodopsin regeneration issue. Allowing adequate time for dark adaptation before driving at night, sitting in a darkened environment for 15 to 20 minutes before getting behind the wheel, is a simple, cost-free strategy that can meaningfully improve your visual readiness. Protecting your eyes from excessive blue light exposure, particularly from screens in the evening, helps preserve your eye's state of readiness for darkness. Blue light is particularly effective at suppressing the early stages of dark adaptation. I want to be direct about timelines and expectations, because this is a responsible health channel. Bilberry is not a pharmaceutical drug. It will not reverse structural eye disease. It is not a replacement for professional eye care. And the suggestion that everyone over 60 will notice dramatic night vision improvements within a fixed number of days is not supported by current clinical evidence. What the evidence does suggest is that bilberry anthocyanins consumed consistently as part of a diet rich in retinal-supporting nutrients may help support the health of your retinal cells, support the efficiency of your visual cycle, and contribute to the maintenance of ocular microcirculation over time. These are meaningful and scientifically grounded benefits, even if they operate subtly and gradually. Some individuals, particularly those whose diets have been low in these specific plant compounds, may notice more subjective improvement than others. Individual responses vary based on baseline nutritional status, the extent of age-related retinal changes, and overall metabolic health. The goal of nutrition for eye health is not to cure aging. It is to give your body the specific compounds it needs to maintain the most efficient visual cycle possible for as long as possible. That is a worthy and scientifically grounded goal. If you found today's content valuable, please hit the like button. It genuinely helps this channel reach other seniors who could benefit from this research. Subscribe if you have not already, and hit the notification bell so you never miss a new episode of Senior Health Insights. And in the comments below, I would love to hear from you. Have you tried bilberry? Have you noticed any changes in your night vision? Share your experience. Your insight helps this community. Until next time, take good care of your eyes. They are your window to everything.